Hi, I'm Bruno Sousa, and I'm here to present CROCUS, which stands as an objective approach to select SDN controllers, let's say, and to perform a security assessment. This work it's the output from of the efforts from Carlos Silva, a master student, and also my colleague João Vilela from the University of Porto in Portugal. Briefly, the outline of this presentation, we will present the problem statement, the motivation for CROCUS, some background terminology, and also how we elaborated CROCUS, the objective SDN controller security assessment, and how we evaluate and the results. Regarding the nowadays, in a network management perspective, we have the choice of multiple SDN controllers, which support different protocols, OpenFlow, P4, NetConf, whatever, and they also provide distinct security support. And how they enable, let's say, the management of the network functions differs between them. And we have also the category, for instance, like RAIU, which are mainly SDN controllers for research purposes, while, for instance, ONUS stands as a networking operating system and is mainly adopted by telecom operators. So in this perspective, if we need, let's say, in different projects, we need to manage network resources, let's say, and these projects have different requirements in terms of functionalities, where we want, for instance, to have the maximum availability levels, so SLA of 99.9, or we also have security requirements in place where, for instance, we need that every usage of different APIs needs to be authenticated or needs to be accounted, let's say, for the time of usage and the type of usage. So we pose these questions: how can we choose the most adequate SDN controllers for our project requirements, and can we also rely this decision on the historical data, on the information that is available regarding vulnerabilities? And to answer these questions, we came up with CROCUS. So CROCUS is mainly, let's say, for SDN, so software defined network, which among others features allows us to perform, let's say, the dynamic programming of the network infrastructure, so to deploy on a dynamic way flows that all provide, let's say, certain characteristics that enforce certain characteristics on the network devices to assure quality of service, for instance. And on this perspective, it splits the control and the data plane functionalities. So data plane is mainly related with the forwarding of packets, while the control is mainly related with the management, so which flows, how they are configured, the frequency of updates, and so on. And of course, the entities that are responsible to manage this are the SDN controllers. And on this sense, the SDN controllers have different APIs interfaces. So let's say in the top we have the northbound interface, where different applications can communicate with the SDN controller, mainly, let's say, to provide or even to gather information regarding the topologies of the different networks. If we think on an east-west interface, so on a failure tolerance, where we want to avoid single point of failures, then the different clusters, different controllers can be organized in clusters, and all the communication, exchange, the synchronization of data is mainly performed with these interfaces. And of course we have the southbound interfaces on which the SDN controller communicate with the respective devices. And this is a simple image of the ONUS controller, which includes different systems and, let's say, support for different, let's say, southbound protocols like OpenFlow, NetConf, Open vSwitch, and so on. If taking the second question, so if we also want to take an historical data regarding the vulnerabilities, then we need to resort to the common vulnerability scoring system, so the CVSS, which, let's say, formulates a score in a range of 0-10. Then for each, let's say, interval, they also, let's say, have different levels of severity: critical, high, medium, low, where the critical, for instance, the critical vulnerabilities need to be assessed. And the CVSS is adopted by developers and different organizations, let's say, to communicate the different vulnerabilities as well as the severity level. And the CVSS mainly combines the different metrics related to vulnerability in three categories: the base, the temporal, and the environment. The base, let's say, are vulnerabilities that do not change with time, and mainly include, let's say, the exploitability and the impact. So if it is easy to exploit a certain vulnerability, and on the success of such exploitment, what is the impact? And there are the temporal vulnerabilities which change over time, or vulnerabilities that are related with a specific environment. So certain conditions need to be in place so that that vulnerability can be exploited. For instance, requires root privileges. To assess the objective selection, we need to resort on a methodology that allows us to place the different choices, to compare them objectively. And one of the techniques and approaches that is followed in the literature is, for instance, to rely on multiple attribute decision mechanisms, which shall provide, let's say, a score and include different steps, but mainly split the criteria into benefits and costs. So for a certain SDN controller, it has, let's say, its strengths, so metrics, for instance, that we want to maximize. So for instance, the number of security features that are supported, we want this to be maximized, or even the level of the security that is supported when to maximize, and others that we want to minimize. So for instance, we want to minimize the impact on a successful exploit of a vulnerability, so the cost, the metrics that we want to minimize. And different steps apply, and we have then a rank, let's say a kind of score that can be ordered, and allows us to compare the different approaches based on that rank. Briefly, this kind of techniques mainly consider the different metrics. So the first step considers the normalization. So because the metrics can have different scales, then what is determined is mainly the ideal values based on the normalized values of the benefits as well as the normalized values of costs. So we consider these the ideals, so those the values of the metrics that have the best values. And then what happens is that it is determined, let's say, the distance of each alternative to these ideal values, and then the distance is aggregated into a score, and then the rank is obtained by ordering this score. So based on these different aspects, topics of the background, mainly SDN, that is our domain of actuation, the CVSS, so the reporting of vulnerabilities, and resorting to the MADM approach, we enable CROCUS. We designed CROCUS as an objective SDN control security assessment. So, and it can be deployed, let's say, in the design phase when we are selecting the different controllers based, for instance, on the analysis of the documentation, on the production phase when it is already running, or we are performing the initial experiences. It includes different steps. So first of all, we need to identify the SDN controllers, and for this identification we can then perform an initial selection where we want, let's say, controllers that already are able, for instance, to support clustering, and on this sense, for instance, for the controllers that we have selected in the use case of the paper, we mainly select Open Daylight and Donos. Then the second step is gathering the information of vulnerabilities, and here we resort to CVSS. We rank the vulnerabilities using the MADM approach, and then we have, let's say, heuristic to perform the selection of the SDN controller. Let's see some of these steps in detail. So after selecting the controllers, we need to gather information regarding the vulnerabilities. So we resort to the CVSS, which has different versions. The one that we have used relies on version 3, and that includes metrics like, for instance, for the exploitability and the impact, as well as the CVSS score. So, for instance, we consider the attack vector, where, for instance, it is related with the physical access to explore the vulnerability. If also it requires what kind of privileges it requires, so high privilege or not. If it requires user interaction, so the vulnerability to occur if it is needs some action from the user, and so on. And given the context that for SDN we also introduced, CROCUS also proposed metrics that apply to the SDN terminology, mainly, let's say, the application plan, the control, and the data plan. So if, for instance, a certain vulnerability affects all of these planes or only one of them, as well as the severity and the probability, and also, of course, if there are mitigation measures, for instance, installation of a patch or something like that. And let's say the step 2 is mainly related with the information that we are able to gather from CVSS databases. Then we employ on step 3, we rank the vulnerabilities. So we have the different values of the metrics for each of the SDN controllers, and then we apply the MADM approach. We resort on a methodical, which allows us then to provide us a score. So we enable it at V score that is mainly provided by applying the MADM approach. On the step 4, we need, let's say, to perform a final decision where we also want to include what? We want to include the vulnerability scores, so coming from the previous steps. We also want to assess, okay, there are a lot of vulnerabilities, but how they are solved, how fast they are solved. So for that, we introduced the solvability ratio, which mainly considers a relation between the number of days on which there are updates regarding the vulnerability, so that this can also make the distinction between an active community or entity responsible for SDN controller, as well as a set of security features that are relevant for the SDN context. And then all of these metrics are combined, say, using a utility function, let's say, to provide the CROCUS score for each of the controllers. And since we are using a utility function, we have then different waves for the different metrics, for the different values, mainly vulnerabilities, solvability, and security features. Regarding the security features, CROCUS also proposes, let's say, different features that are relevant in terms of what? In terms of the design, in terms of the interfaces that the SDN controller has, as well as service, but in a security perspective. So for instance, if it supports, for instance, multiple instance or not, and for instance, regarding the multiple instances, if there are some protection regarding the messages that are exchanges, let's say, to avoid attacks like one aiming to act as the master controller, and for instance, if all the information is securely stored. Regarding the interfaces, of course, if they support TLS in the different interfaces, so southbound and northbound, for instance. And of course, if they are also integrated with the other security services, for instance, with IDPS or deep packet inspection for further security analysis and so on. And given the proposal of CROCUS, then we wanted to assess and, let's say, have a decision regarding ONUS and open the light. So for that, we establish a study period from 2014 to 2080, and then we consider different sets for the waves. So for the benefits and for the costs, for all uniform, where all the criteria is equal in each of the categories. SDN, let's say, set where we put more relevance to the SDN metrics. So for instance, if the vulnerabilities affect the application plane, the metrics related with the CVSS, so regarding if it requires the user intervention or not, as well as the CROCUS set, mainly those metrics that are introduced, so the number of mitigation measures, the security level, and so on. And based on the study period, what we then were able to determine was, let's say, the update days for the Open Daylight and for ONUS, given the different the different vulnerabilities, and then the ratio of solvability with huge difference between open daylight and onus, but for instance we also need to consider here that for the same period onus has a higher number of vulnerabilities that were reported. Our results in terms of, for instance, for the vulnerabilities, let's say put a preference on onus. So for instance we see a higher oscillation, but the minimum values are lower in onus, and let's say this leads to a preference regarding onus. Also, one thing that we also should mention is that either onus or open daylight, in terms of features, they are almost similar, and if we consider the security features that are supported, open daylight appears as the preferred one. If we combine those metrics, let's say, into the CROCUS score, the one that was proposed, we can see here that onus, let's say, tends to be the most beneficial, either by having, let's say, lower values, but also the variation of the CROCUS score is higher, mainly considering the information from the vulnerabilities that were presented. And now what we are, let's say, doing in the research projects, we are using onus configured in cluster mode, and we are integrating onus to share the information regarding the topologies in a secure fashion. And more details are on the paper, but I'm more than glad to provide further details if required. So feel free to drop me an email and stay safe.